respected teachers and my dear friends, a very great morning to all of you. Myself Simran, the student of 11th Science Standard, and today I am here in front of you for mastering the concept on the topic of surface tension. We all know that surface tension is a topic from physics. So, physics is the branch of science which deals with the study of nature and natural phenomena. So, let's return to our topic, which is surface tension. Have you ever wondered how do some insects float on water? Why are raindrops spherical in shape? You might have seen that water wets us but not the ducks which float in it. Also, whenever we try to mix water and oil, they do not mix with each other, whereas oil forms a layer on the surface of water. What do you think? What could be the reason behind all these activities? The reason behind all these activities is just the same, which is surface tension. So, if I would define surface tension, then it is the property of liquid by which its free surface, not the whole liquid, it is the property of liquid surface which tends to acquire the minimum surface area. Means due to the property of surface tension, the liquid tends to acquire the minimum surface area. We have already studied in our earlier classes that liquid have no fixed shape but have a definite volume. So whenever we pour some liquid in some container, they acquire a free surface, and this free surface acquires some additional energy, some additional property, and this phenomena is known as surface tension. Now let us discuss what is that additional property of free surface of liquid. So, whenever something is kept on the surface of liquid, the liquid surface behaves as a stretched membrane, like an elastic or a rubber band. You know that whenever we stretch some elastic and some rubber, it regains its shape when the force is removed. So the surface of liquid also behaves just the same. Now you might be thinking that whenever we place some object on the surface of liquid, then its weight must make it to sink in water. But what is that thing which keeps it float on water? That is surface tension, because the body is balanced by both the forces. The weight of the body acts downward and the force of surface tension acts in the upward direction. Also, it is the answer for this question that why water striders can float on water. So, whenever water striders sit on the water, water behaves as a stretched membrane and it keeps the weight of the body balanced by the surface tension, which is actually an up-pulling force, means it pulls the object in the upward direction and its weight keeps the object in the downward direction. When these both forces are balanced, then the object can float on the water. Now, if I would try to make you understand the surface tension numerically, then surface tension is the force acting per unit length. It is basically denoted either by S or by capital T. So, for the formula for surface tension is force upon length. The dimensional formula for surface tension is mt minus 2, and the unit for surface tension is Newton per meter, which is in SI units. Now, there is a very important question that why does mercury not wet the wall of container whereas water does? You might have seen that whenever we pick out the water from some container, you might have seen some little droplets on the wall of container. So this is why this question is here, that why does mercury not wet the wall of container whereas water does? Now this is the effect of adhesion and cohesion forces. So what are adhesive and cohesive forces? Cohesive forces or cohesion is that property of same molecules by which they stick to each other due to their mutual attraction. Now I would make you understand it with the help of an example. Suppose we are taking an example of water molecules. So if water molecules, the same molecule of water, have the property to stick with each other, then the force would be known as cohesive forces. Now what are adhesive forces or adhesion? So adhesive forces or adhesion is that property of different molecules or two different surfaces by which they cling to each other. For example, whenever we pick out the water from some container, then few droplets are stick to the wall of the container. So the force between that droplets of water and the wall of container would be known as adhesive forces. Now we can understand that when the cohesion forces of the liquid are very stronger than the adhesive forces, then the liquid would concave downwards, and when the adhesive forces of the liquid are stronger than the cohesion forces, then the liquid would concave in the upward direction. Now the answer of the question that mercury do not wets the wall of the container whereas water does is that water wets glass and spread on it because the adhesive forces between the liquid and the glass are very stronger than the cohesive forces. Whereas mercury does not wets the glass because the cohesion forces with the drops are very stronger than the adhesive forces between the drops and the glass. Now here comes a very important topic, which is angle of contact. In simple words, angle of contact is defined as that angle which is between the wall of the container and the surface of liquid. So the angle of contact is the angle between the meniscus, that is the surface of liquid, and the wall of the column of liquid measured from the vertical wall. I need to tell you that the angle of contact for water is less than 90 degree, which is an acute angle, and angle of contact for mercury is more than 90 degree, which is obtuse angle. Now here comes our last topic, which is capillary action. You might have studied this concept before this as well. So capillary action is basically the rise of liquid in the capillary tube. So capillary action is the rise of liquid that wets a tube up the inside of a small diameter tube, that is capillary, immersed in a liquid. As water have concave meniscus, that's why it has the property of capillary action, whereas mercury have convex meniscus, due to which it do not rise in the capillary tube. So if I would tell you the example of capillary action, so the best example of capillary action is seen in plants, because the transport of water and minerals takes place due to the capillary action in plants only. Now if I would tell you a few more example of capillary action, then the first example would be a sponge. Whenever you put the sponge in water, then it would absorb water, and if you would squeeze it, then the water would come out from it. This is also due to the capillary action only. Also you must have seen a diya. Whenever you put some oil inside it, the wick would absorb the oil and it would lighten up. So these were the example of capillary action. So that was all about surface tension. Hope you have all loved the session. Thank you and have a nice day.